58. Two hypothetical salts, LM2 and LQ, have the same molar solubility in water, H2O. If the KSP for LM2 is 3.20 times 10 to the negative fifth, what is the KSP value for LQ? Okay, so let's see. What information do we know more about? Do we know more about LM2? Did I say LMQ? If I did, I apologize. LM2, LQ, LMQ, tomato, tomato. I might be saying LMQ. I'm sorry. It's just the way that my brain works. So, what information do we know more of? LM2 or LQ? Well, they did tell us that the KSP value for LM2 was 3.20 times 10 to the negative fifth. So that's, this is the only number that we know. So we have to start off with LM2. Okay. Now, they told us that we had, KSP value. So we have to write a balanced equation. If we're talking about solubility products, the compound that they're giving us has to be a solid. So I'm going to start there. LM2, that's a solid, and this dissociates into its two ions. And in this case, the two ions are the two different letters. So we have L and we have N. Now, if we just take it at face value, what are the charges here? Well, we have one L and two M's. So we could do the crisscross method. This one crisscrosses up, telling me that the M was a -1 charge, and this 2 crisscrosses up, telling me that the L was a +2 charge. Okay, now since we have charges, this is going to be AQ, AQ, and now let's just balance it. We do have two M's, so I do have to put a 2 in front of there, and now we're good to go. Okay, now we're setting us up for KSPs, so let's just write out the formula for what the KSP would be for LM2. The general formula is this right here. It's just equal to the products raised to the coefficients. So in our case, our KSP is equal to L2 plus, whoa, what happened there? There we go. Times the concentration of M minus, but this one I need to square because I do see a 2 in the front. Now, they did tell me that the KSP is 3.20 times 10 to the negative fifth, but I don't know what these values are. Well, that's where we're going to use our variables. I go back to here and I say, okay, I don't know what the concentration of L2 plus is, so I'm just going to label that as X. Remember, always keep it with your coefficient, but since there was a 1 in front of the L, this is technically 1X. So 1 times X is just X. But in this case, if I label this as X, I have to bring that 2 down. And this is now 2X. These are your variables that you're going to be using. So the L is just going to be X, and the M is going to be 2X. So let's go for it. 3.20 times 10 to the negative fifth equals, maybe I'll close that up a little bit like that. We have X times 2X squared. Let's work on the 2X squared. Remember, anything that's squared just means that you have 2 of the things that you're in, that you have in the parentheses. So you have 2X times 2X. 2 times 2 is 4. And you picked up a total of 2 X's. So 2X squared is just the same as 4X squared. Okay. Now just pick up that other X. So I have 3.20 times 10 to the negative fifth equals 4X cubed. Divide by 4 on both sides. We want to get X by itself. So 3.2 times 10 to the negative fifth divided by 4. I get 8 times 10 to the negative sixth equals X cubed. And now we can just do the cube root, right? But what I like to do for anything above the square root, I just like to raise this to the inverse number. Raising it to the third is 3 over 1, so I can just raise this to the 1 over 3. But you could do the cube root. Let's see if we get the same answer. So these will cancel. Bye-bye. Now we're left with just x equals, let's see, that raised to the 1/3. I get 0.02, and that's a molarity. And remember, your x value is always going to be for your starting compound because you'll always have just one of those. So this is the molarity for LM2. And if you're solving for x, the concentration of the compound, that's your molar solubility. Now, they did say that LM2, the one that we found, has the same molar solubility as LQ. So I can use that to my advantage. I'm just going to move this over to the left side because we're going to now do the other one. Maybe I'll just put like a little line here. Beautiful. And now, since they said that we have the same molar solubility, the 0.02, that's the molar solubility for LQ. So now I know that I have 0.02 molarity of LQ. We now need to find out what that KSP is. Well, got to write a balanced equation, right? L and Q, that's the compound, so that's going to be the solid, right? So let's go for it. LQ, double arrow, talking about KSP values equilibrium. This breaks down into its two letters, L plus Q. Now, we don't really need to get the charges perfect for this, but just know that since we denoted L as a +2 here, it should be a +2 as well here. I mean, it could be different charges. The charges doesn't really make a difference. It's the numbers in the front that make all the difference. So if it's a 1-to-1 and we labeled L as a +2, Q should be a -2. But maybe L was a metal, L probably is a metal because it has plus charges. Maybe it has two different charges, a +2 and a +1. It really doesn't matter. But just make sure that here, it's a 1-to-1-to-1 ratio and you're not putting like a 2 in front. So now, since we said that the molar solubility for LQ was 0.02, we can use our mole ratios. And just like we said, it's a 1-to-1-to-1 ratio. So whatever you started with, those are the numbers that we're ending with. So maybe what I'll do is I'll just bring this down here. And for both L and Q, you both have 0.02 molarity. Now, because we know the values, this is what's going into our KSP equation. Remember, the KSP equation, if I just bring this over, just products raised to the coefficients. In this case, it would be KSP equals the concentration of L 2 plus times the concentration of Q 2 minus. They both equal 0.02 and 0.02. So KSP just equals those two values times together. And then that would be the KSP. So KSP equals 0.02 times 0.02 is 4. And I guess we'll do 4.00 for sig figs. Does anybody care? No. 10 to the -4th. And that's it. There you go. Okie dokie. So that's the KSP for LQ. I really hope this helped. Thank you so much for viewing the video. Subscribe to the channel and tell your friends, tell your classmates about this YouTube channel. My brother and I, we just want to help as many students as we can. Right now we have physics, math, and chemistry videos on the channel with more subjects coming your way. So stay tuned. Okay? Okay. Bye-bye.